So just to recap, so we have three things going on here, right? We have the tide is pulling the sand into the ocean, going away, right? We have, guys, we have pumping station adding sand to the beach, okay? So things leaving, the rate is R of T. The pumping station putting sand on the beach, that rate is S of T. And then we have sand that was already there, right? So the last thing we did was if we want to find out how much sand is on the beach at a certain time, right? That's the total number. So after 3 hours, how much sand is on the beach? We would plug in 3 for T, right? That's what we came up with last. That's the last thing we did, okay? So now the question is, C, find the rate at which the total amount of sand on the beach is changing at time 4. Notice how I highlighted things. Why did I underline and highlight those things? Take a look at it. Read it again. Those little words, those little buzz phrases will let you know what to do. Okay? So take a look at it. Take a look at it. So why did I highlight rate? Why is rate important? Okay. Why else is rate important? Why is rate important? Anytime you see the word rate or anytime you see the word rate of change, why is that important? Yeah, if you see the word rate in this class since September, if you see the word rate, first thing in your head should be derivative. Very first thing in your head should be derivative. Okay? Those are the things you have to look at when you're looking at problems. They will tell you what to do in the problem, but you have to know where to look. And like I said, we've been having the same conversation since September. Anytime you see rate of change or rate, you're going to think derivative. What am I finding derivative of? We'll find out in a second. But you have to think derivative when you see rate. Okay? We might not need to find derivative. I might already have derivative, but that means derivative. Okay? Slope of the tangent line, derivative, right? All of those things, derivative. Okay, so that's the reason I did that. So the rate of what? In other words, the derivative of what? What else is up there? Mm-hmm. Okay, so why did I underline that? Why did I underline? We know why I highlighted rate because I know I need a derivative. Mm-hmm. Are we going to be using the same equation from letter B? So does total amount of sand sound familiar in this problem? Where? Go find it. Where does total amount of sand, where did you see total amount of sand? From part B, right? So this problem is really solving itself. But if you don't know what to look for, it's hard. So it's saying find the derivative of the thing you just did. That's all it's saying right there, right? That's all it's saying. So when you see a test, you won't have any of this, right? That's the stuff that you need to start thinking about in your head when you see these problems, right? It's coded. It's all coded, but it's all there, okay? If it says find the rate of which the total amount of sand is on the beach. Well, rate means derivative. Check. Total amount of sand. Do I have an equation for total amount of sand? Yeah, we just did that, right? Isn't that what we just did right here? At any given time? So what this is saying is take the derivative of the guy you just solved. Okay? So that's what we're going to do. We need to find y prime of t. Okay? So y prime of t, how do I find y prime of t? What is it going to be? Oops. If we don't know, we're going to have a quiz, because we've already done this part. We were going to have a quiz on Monday about all of this stuff that you guys took a test on. Because you guys took a test on this stuff already. How do we find the derivative of y prime? No, that's not derivative. Ooh, maybe we will have a quiz on Monday. Hmm? Okay.
Not 0, 2500 G, sorry. And then
no, you were right the first time.
Integral.
You're right the first time. You're right the first time. If we find the derivative of this guy here, that's what I'm doing. I'm finding the derivative of this guy here. 2500 is just a constant, so the derivative of a constant is 0. Now, how do I find the derivative of an integral? Cancels out the integral, right? Integral and derivative cancel each other out. So you're just going to end up with s of t minus r of t. No more dt. Right? That's the derivative. Now what do I need to do?
Plug in t equals 4.
Now plug in y prime is 4. 0 plus s of 4 minus r of 4. What do you get? Okay, so whatever you need to do, underline, highlight, circle. You don't have to do, I'm not asking for math yet. I'm just asking for math thinking. Math thinking. Plan. Formulate a plan. What am I going to do here? Mm-hmm.
Right off the bat, I'm noticing a few things. Minimum value, we're going to be using the first derivative.
So minimum value means first derivative. Of what? I'm not sure yet. But that's important, right? That is important. If you can see that this means first derivative, you're ahead of the game. Okay. What type of minimum? Because we have different minimums, right? We have relative and we have absolute. So what type of minimum are they suggesting?
If they don't say if it's a local or relative, we know it will be an absolute.
So yeah, they're saying absolute. Another reason for that is because they give you an interval. Anytime they give you an interval and they don't say anything about relative minimum, it's going to be an absolute. So they're looking for an absolute minimum. You guys just had a question like this on your last test. It talked about an absolute maximum or minimum. Okay, good. So we know we need to find a first derivative, and we need to do to find an absolute minimum. Okay, now our objective is what? First derivative of what? What do we need to find derivative of? Minimum of what, I should say. Minimum of what? The minimum rate? The minimum amount of sand? What? What are we looking for? The minimum what?
Could be amount of sand.
Yeah, I just underlined it, right? I just underlined it. That's the part I underlined right there. Amount of sand, right? Amount of sand. If we want to know amount of sand, we're going to use this guy right here, right? That's the guy we're going to use. If we want to know something about the rate, we're going to use these guys, okay? They didn't say anything about rate. There's nowhere in there that says anything about rate. It's amount of sand, right? So we need to find first derivative test for this guy right here. First derivative test for this guy right here. So what do we need to do for first derivative test? How do we do first derivative test?
We find the derivative of y of t, but we already found the
Okay.
derivative right there.
All right. So y of t, so we need to find derivative of y of t, which is y prime. So let's write that down. So it's really just s of t minus r of t. Good.
We set it equal to 0.
So we got to figure out where this is equal to 0. How do we figure out where it's equal to 0? See if anyone was paying attention a couple days ago, because I specifically taught about this. I'm like, you're going to see something like this. If you rewatch the video from a couple days ago, I don't know, I think it was on a video, when we were doing a calculator. It's on in the notes. How are we going to do that? Okay, what are we going to do with the graph? What did I, yeah, exactly. When we graph two things, wherever they cross is what?
They intersect.
Okay, but what does that mean? When they cross, when two graphs cross, this is what I'm talking about here. You got this is one of the things you have to be able to. Two graphs cross. What does that mean? When two graphs cross, they intersect there. What does that mean? I know they intersect, but what does that mean?
At one point, wait, no, hold on, let me think about it.
What does that mean when two graphs cross? What does that mean? I wouldn't be asking you this question if I didn't specifically give you the answer a few days ago. And I said, because I knew this day was coming, because it happens every year.
Does that mean both rates are the same at that
They're
point?
equal. They're equal. That means both are equal at that dot. Okay, I'm saying it for a second time. They're equal. So if it's on a test, I'm not going to feel bad. They're equal. They are equal. Okay? So how does that help us with this guy here?
We add r t to 0, and then wait, no.
No, we don't need to do that. You can, but how will that help us? How will what I just said help us here? Mhm. Okay, so what should we do next? What should be our next step?
I think graph them and then the points that they're intersecting would be the p-values or the critical.
There you go. Yeah, didn't I just draw a picture of a graph? Graph them. Graph them. Graph them. Both. X2 plus 5 sine 4x. Let's see. All arguments entered. Y, let's see. Okay. 2 plus sine. Oops. No. 5 sine 4 pi x parentheses. No. Divided by 25. Zoom. Decimal. There we go. Okay. So if you can't get it, just look up here. Okay. If you're not able to get a picture, it's fine. Just look up here. Okay. So now, how do we figure out where they intersect? How do they figure out, how in the world do we figure out where they intersect? Because we said where they intersect, they're equal. And if you subtract two things that are equal, you'll get 0, which is what we want. So how do we figure out where they intersect?
On a calculator on how to figure that out.
Okay.
Since we can't find, this is just a zoomed in portion. So you have to go to the zoom function and then go to zoom out.
Okay.
You should see some other points.
And that'll tell me where it crosses?
It should show you.
No, we did this the other day.
We can go to calc and then there's
There we go. Go to calc. And then there's a intersection button. First curve, second curve. My best guess as to where they cross, probably somewhere off the graph. That's where they cross. You don't technically need to see where they cross. The calculator can see that. You can zoom out if you want, but that's where, right? Get to know your calculator, guys. You guys are on your phones all day, every day on your phones. Take 10 minutes away from your phone and just play with your calculator. Play with your calculator, okay? It's got a lot of stuff that it can do, but if you don't know how to do it, it doesn't serve its purpose, okay? So it looks like it crosses when x is 5.118. 5.118. What do we do with that? Okay, so we're going to need to make a table. Okay. What are we going to put in our table? This is stuff you should know. This is stuff you should know. This isn't new stuff. You've had this type of question on the last test and a test last semester. If we don't remember that, like I said, it can be on the next test if you want to. Yeah.
Stuff that we would include in the table would include the endpoints of the interval.
So the endpoints are 0, 6. What else?
Our 5.118 point that was at the that was
Okay, so that number is a what? What do we call that? Critical point, critical value. Anything else we need to put on there? Okay. So now, how do we figure out which one was a maximum, which one was a minimum, and which one was neither? Plug them in. Where do we plug them into? The original, not the derivative, the original equation. So plug them into the original equation and tell me what you get. Use the calculator to plug it into the original and tell me what you get. So when you plug in 0 to the original, you're just going to get 2,500, the 25 initial. When you plug in 5.118 to the original, you're going to get 2,492.369. And when you plug in 6 to the original, you're going to get 2,493.277. Okay? So the lowest one is the minimum. That value is that number right there. And that's at time 5.118. So when is the lowest amount of sand going to be on the beach? At hour 5.118. Okay, so each of those, when you plug it in here, you'll get that value. 0, you don't even need to do, because 0, the integral from 0 to 0 is just 0. So that one is easy. This will be 0, so you get 2,500. Then you plug in 5.118 into the calculator, and you plug in 6 for the calculator. Okay.
quick question. If you're plugging in the values, do you plug in the values? I always say this: do you plug in 5.118 inside the interval for S of t and R of t, or just with?
No, you could just put the whatever they are. Watch, I'll show you a quicker way to do it. And it's going to be recorded, so you can always look at it if you want. I'm going to show you a quicker way. I have both of the values, R of t and S of t, in my L1, or in my graph, right? Okay. So let's say I'm trying to find for 5.118. So I go math, 0 to 5.118. Now here's you put the function in. It's S of t minus R of t, right? S of t minus R of t. So when you're putting them in, they're long. They're long, right? It works. It works. The way you guys did it will work. But here's a shortcut. R of t, or sorry, S of t is y2. So really I'm going y2 minus y1. That's what I'm doing. I'm subtracting the bottom one minus the top one, right? That's what I'm doing. Wait, no, the other way around. No, that's right. The bottom one minus the top one. So the calculator has this little button called vars. Vars. I'm going to say it again. Vars. It's the only one that starts with a V. Vars. And then you go to yvars. And then you go to function. Then you have a bunch of y2s and y1s. So really what I want to do is I want to go y2. Oops, no, not right there. What was it supposed to be 2? Okay. So you go back to where you were. In here. No. Sorry, my computer's going really slow right now. Okay. 0, 5.118 bars minus bars okay. So instead of having to write it all over again, you already have it written down, right? The calculator will let you shorthand it. And then when you calculate it, wait, what? That's not the right answer. When I messed up, I think I switched those guys up. But that it'll let you do that, okay? It'll let you do that. I'm not going to take more time to do it, but I think somehow it got.
I think you were supposed to put a 2,500 plus at the front.
There you go. Yeah. Yeah. So I would just go plus 2,500, right? So that answer plus 2,500. There we go. Thank you. Okay. All right. There's a reason I record all of these things, right? There's a reason I record everything that's on my screen up here that you can see. There's a reason. So you can go back and look. But if you're not going back and looking, I'm not going to feel bad for you, right? I can see who watches the video and who doesn't watch the video, right? So if you're struggling and you're not watching the videos, I don't feel very bad for you. But if you're trying and you're struggling and you're watching the videos, then you want teachers to feel bad for you, because then they go easier on you, okay? So make sure you use your resources, okay? Yeah, question?
It's 2,000, it's for 5.118, it's 2,492.
2,492.369?
Okay, because for some reason I have 2,498. It could be an error on my
I don't know why. Yeah, that's the number I had in my notes. Okay. The better you are with your calculator the rest of the year, the easier this will be. Okay? Because every question I give you, you've done before. But the calculator, that's what I said at the beginning of the year. I said, we don't use the calculator a lot in this class, but you almost kind of dread when we can use the calculator, right? Everyone's like, oh, I want a calculator. Yeah, but the stuff we can use a calculator on, it's heavy duty stuff. It's heavy duty stuff. So, it's the saying, Be careful what you ask for because you might get it. Now you can use the calculator, but it's heavy stuff, okay? Okay, so here we go. Example number 4 now. Example number 4. Karen rides her bicycle along a straight road from home to school, starting at home, time 0 minutes, and arriving at school in time 6. So it takes her 12 minutes to get to school. She rides her bike. During the time interval 0 to 12, her velocity is modeled by the piecewise linear function shown to the right, and it's a calculator question. So this shows her velocity. Okay, this shows her velocity. Okay. Find the acceleration of Karen's bicycle at time 7.5 and make sure you indicate your units of measure. How are we going to do this? Underline, highlight, circle. Keywords, buzzwords. Not everything. One thing I would definitely highlight, circle, underline is acceleration, because we don't have acceleration, we have velocity. 7.5. So we need to find acceleration at 7.5. How do we find acceleration?
First derivative, or take the derivative of v of t.
So derivative of velocity. Derivative of velocity. Okay, so what is velocity? Where is velocity? The graph, right? They don't give us an equation. They say the graph. So when I say first derivative of the graph, what am I saying? Slopes. Slopes of the graph. So in other words, we're saying slope of the graph at 7.5. So we're saying slope of v of t at t equals 7.5. So let's go over and find out where 7.5 is. 7.5 is right there, right? It's part of that little segment there. What is the slope of that little segment there? Well, yeah, it looks like, so rise over run, right? Rise over run. So it looks like it goes down a unit and over a unit, okay? So down a unit doesn't mean a whole unit. It means 0.1 of a unit, right? So it's down 0.1 of a unit and over 1 unit. All right? So that's the same thing as just 0.1. Okay? Units of measure. Units of measure. It's acceleration. So how do we measure acceleration? It's a rate.
It's miles per minute squared, or
So if it was velocity, it would be, this one's miles per hour, right? Or per minute, it said. If it was velocity, but it's acceleration, so it's going to be, yeah, the time is going to be squared. The time is going to be squared. Because it's a rate of a rate. That's what acceleration is. It's a rate of a rate. Okay, there you go. The answer, the keys to the question are in the question. You just have to be able to pick them out. They're always going to give you enough information, but you just got to know what to look for. Part B. Part B says, using correct units, explain the meaning of the integral 0 to 10 for the absolute value of v of t in terms of Karen's trip, and then actually find that number. Okay. I highlighted that. Why? Some of you are doing it. Some of you know what to do. Looks familiar, doesn't it? We've seen that before.
We're seeing that on the first page.
It's right there, right? And what did that represent?
The speed, absolutely.
The total distance traveled, right? So it's going to represent her total distance traveled throughout the whole trip. 0 to 12. So that's the explanation, okay? So we're going to say represents the total distance Karen traveled over the 12-minute period or interval. That's what it represents. Okay, so then we have to find this. So I go to my calculator, right? No, why don't I go to my calculator?
You aren't given an equation.
Because I have nothing to put in. Okay, so I can't put anything in my calculator, so how do I figure this out? What is this? What is the, not 212. What is this asking? It's the total distance traveled, right?
It's the area under the curve.
It's area under the curve. Area under the curve. Okay, so I have here, right? Let me erase this part because I don't need it no more. So area under the curve for everything?
Absolute value.
Absolute value. So how is that going to change how I do this?
So from 2 to 4, that's also going to be positive.
There you go. Yeah, everything's going to be positive. So anything that's below will still be positive. So find area under the curve. Everything is positive. There is no negatives. Everything is going to be positive. There is not going to be a negative in this case because it's absolute value. Break it up into little parts. Triangles, rectangles, squares, trapezoids. The first two are exactly the same. The first two are triangles, and they have a height of 0.2, a base of 2, and you divide it by 2. So that means they're going to each be 0.2. 0.2. Positive 0.2 since it's absolute value. The next one. Well, I can do this several different ways. I can break it up like this. So I have a triangle here. The height of the triangle is 0.3. The base is 1 divided by 2. You're going to get 0.15, I believe. The next one is just a rectangle, 1 times 0.3. The next one is a trapezoid. Trapezoid, you're going to go base 1 plus base 2. So 0.3 plus 0.2 times the height divided by 2. So it's going to be 0.5 divided by 2, which is 0.25. And then the last one is a trapezoid as well. Base 1 plus base 2. So let's see. 3 plus 4 divided by 2 times the height, which is 0.2. So that's 7 times 0.2. What is that? 0.14 divided by 2, 0.07? No, that seems small. Let me get my calculator out so I don't make a mistake. Should be 0.7. 7 divided by 2 times 0.2, 0.7, yeah. I had 0.07, it should be 0.7. 0.7. Okay, add them all up. They're all positive. When you add them all up, you get 1.8 miles. 1.8 miles. That's how far she traveled. Okay. All right, we'll do one more. One more, we'll be done for today. One more, we'll be done. Letter C. Or sorry, that letter C. And then D is the big question. D is the question you might see hint on a quiz, on a free response question. We'll do D on Monday, but C will be where we finish. C. Shortly after leaving home, Karen realizes she left her calculus homework at home and she needs to return. Okay? At what time? Where does she turn around and go back home? And how do we know? So at some point during her 12-minute journey, she had to go back home. She had to go back home to get her homework. Where and how do we know? Where is it and how do we know that's where she left off?
Where it goes under the x-axis.
Okay. So I don't want to write that. So where does she go? So those of you that are, what do I look for? What can I do? If she goes back home, what does she have to do? She just turn around, right? Turn directions, change direction, right? If she changes direction, well, it said in the question velocity, but if she changes direction, what does she have to do? What does she have to do if she changes direction? She just has to stop. Right there. Object stopped. Right? Object stopped. Right? Where does stop on the graph? How do we know that?
Because that's where it reaches 0.
There you go. When velocity is 0, right? At 2 minutes, at minute 2, right? At minute 2, right there, right? That's where velocity is 0 because she had to turn back and go home. Okay, so let's write that down. At time equals 2 because velocity changes signs. Velocity changes signs. Okay. There's another time it's 0, right? Where else is it 0? Yeah, it's right here. What the heck's going on here? She's at home. She's not going anywhere, right? She's getting her homework. From minute 4 to 5, she's getting her homework. Okay? And then what happens here? How do we know that? Because the velocity is 0, right? She stopped again. She stopped again, right? I'm guessing at the end, because there's no more part of the graph, right? She stops, right? So even though it's not asking us those questions, it's something we should know. Because, hey, on the next question, they could ask us that. On the next question, they could say, when is she at home? When does she get home? Well, minute 4 to 5, right? Because there is no velocity over that minute. There's no velocity over that minute. Okay, that's the reason why. Okay, you want to be as specific as possible. You want to treat the person who's reading your test like they know very little calculus, if any at all, right? So you would say, at minute 4 to 5, she stopped. She's at home because velocity is not changing. Velocity is 0. Okay? So when your explanations, just make sure your explanations are clear to someone who maybe can read a graph but doesn't understand what you're doing. You always want to give good explanations for that, because I know a lot of you guys have the answer. You're like, oh, I got the answer. When it changes, I get that a lot. It'll be like, where does, I'll ask the question, where does she turn around? Where does she turn around? Oh, where it changes. I think I know what they mean, but that's not enough to give them credit, right? You have to explain. Well, when time equals 2, because velocity changes signs. That's an explanation I can grade, right? So just be clear with your explanations, okay? All right, okay, so we're gonna start with letter number 4. Number 4 is a great problem because it involves a graph and it involves an equation, okay? So, or 4D, sorry, 4D, okay? So that's the one we're gonna start with. If you wanna preload yourself,